Hi, this is Adela Lemus from Instituto Politécnico Nacional. It is my pleasure to present our recent work entitled Dimethylformamide in Hofmann type coordination polymers. As an introduction, I need to talk about Hofmann type coordination polymers. This class of solids are built from tetracyanonickelate anions and transition metals, which basically form a bidimensional structure. From metal centers in octahedral geometry that you can see here, there are available apical coordination sites that stand there in two specific directions at regular distances and conformations. This type of layered cyanometalates have proven the ability to adapt the gallery to different shape, volume, and nature of the organic ligands. The interlayered space, with still some degrees of freedom, favors specific configurations highly orientated due to massive weak interactions between neighboring molecules. The coordination of single molecules to metal centers in these layered materials is a methodology to expose weak interactions, usually hidden in bulk. In this research, we investigated the intercalation of dimethylformamide, which is a widely used organic solvent and reagent in various industrial and laboratory applications. It has a high boiling point, low volatility, and good solvating power for a range of organic and inorganic compounds. For the experimental part, I can share with you that the preparation is very easy. We start with aqueous DMF binary mixtures to dissolve potassium tetracyanonickelate and transition metal salts of manganese, cobalt, nickel, and zinc. Reaction mixtures were stirred about 1 hour, and then they were left in darkness for 1 week. The precipitates were separated by centrifugation and washed several times with a mixture of water and ethanol to remove residual species. Finally, solids were air dried, also in the darkness, to constant weight. The nature of the obtained solids was confirmed by infrared Raman and UV spectroscopies, which is what we have here in these figures. The crystal structure of the isostructural family was solved ad initio by direct methods using the SG6 program from extracted intensities from the powder X-ray diffraction patterns from extracted intensities according to the Veil method. The structural refinement was carried out by using the Ripple method, which was implemented in the full-proof program. As results, we have 4 new solids that crystallize with an orthorhombic unit cell in the I2/M space group with average salt parameters A equals 1498 angstroms, B equals 7.43 angstroms, C equals 6.81 angstroms, and beta 95.14 degrees. DMF intercalates in Hofmann host galleries by means of oxygen coordination bond to the transition metal. The infrared spectra of the formed solids appear as the superposition of the spectra of the inorganic Hofmann coordination polymers and the organic DMF blocks. But also we can observe there are specific shifts in absorption bands, for example, for stretching carbonyl stretching, carbonyl, stretching of carbon-hydrogen bonds, and bending of carbon-oxygen-carbon. The only one shift downward is the carbonyl stretching, and the rest of the important shifts are upward shifts. The principal Raman frequencies also confirm the presence of carbon-hydrogen, carbon-nitrogen, and carbon-oxygen chemical groups in the title family that are characteristic from the dimethylbromamide organic compound. Absorption spectra of the studied family confirm the octahedral geometry of the transition metal cation. Magnetism studies are currently being carried out to identify the presence of weak interactions, which is one goal of the project. For acknowledgements, I need to acknowledge the financial support of CONACYT by means of the project Ciencia Básica y de Frontera 2023-2024-2705, and authors thank the access to the experimental facility available at Laboratorio Nacional de Conversión y Almacenamiento de Energía, Project 279953. On my own, I also want to thank you for your attention to our work. Thanks a lot.